Hello, good morning to everybody. This is a small session we are recording to make understand engineer how we are conducting our training program. Our face is not visible, it has been hide, but during training that will be visible. We are sharing our laptop screen to you, okay, our LinkedIn screen. So it makes you a sign that how you can see our screen. In design, there are two topics. One is the basic engineering, other is the detail engineering. Now, what is basic engineering? Basic engineering relates to formula, application of formula, and formula tree. And detail engineering, once the major parameters of the machines are taken decision by application of formulas, it is been plotted to detail engineering by making component to component drawing. Then an assembly drawing has been made. And that particular assembly drawing has been simulated. But a basic engineer knows that how my load is been getting transferred from component to component and how he has arrived at the final HP of gearbox or motor. What is the initial starting load calculation? We have seen very good number of design engineers at present. Earlier before 20 years, there were not that much design engineers. Design engineers once 20 years before you say means you are called Khatu. But because of this software penetration, NC, SolidWorks, VO, CATIA, Inventor, automatic Khatus have been produced. But majority of the design engineers at present are doing detail engineering, making drawings and doing some simulation. Doing some kind of weight reduction in drawing. But they don't know the formula which is running behind. All softwares are being programmed by formulas. If you have command on this particular formula tree, then you can design anything, any component, any machine. But you must understand how this formula tree is been made, from where this particular formula tree will start and how it will end, and how in between my load will get transferred from component to component. So in our training, 5 popular topics we are taking. One is the machine structure load. Other is planetary gearbox and spur gear. Third is lubricants. Fourth is metallurgy. And fifth is machine hydraulics. With increasing number of say tonnage of loads, big machines, big size equipments are being manufactured, electrical motors, they are very tough to be installed at particular locations. So hydraulics is a very popular and very reliable hydraulic system. Motors, hydraulic pumps are available. So now majority all equipments, machines, they are running on hydraulics. Metallurgy, you understand that without metallurgy, engineering is not possible. By changing the load, by changing the YP, UTS or hardness of material, how you can improve the performance. If I am changing my gear material from EN8 to EN24, how my performance will improve? What size reduction is possible? Majority engineers don't know what is lubricant. 75% of the design, mechanical designs fail because lubricant is not taken care while designing the machine or mechanical system or even bearing. There are some 20,000 types of oils and 10,000 types of greases. Engineer must know what is oil, what is grease, so that he can improve performance of his design. The design doesn't end in a failure. But if any, say, emergency, a certain behavior is seen, then you can understand that why this kind of behavior, how can sort out with the help of a lubricant. We take direct planetary gearbox. We have derived a 5-step design process in planetary gearbox. Irrespective of any size, any HP, any reduction ratio from 0.5 to 1440 RPM, you can design by your own self. We will make you design. Particularly, we make you design everything. We only act as a guidance. Like this, our screen is running in front of you. Your formula flow will run and will make you think that how to start this flow design, from where to start this particular mechanical press. Why the flywheel size is like this? What kind of loading is happening here? Okay. So we have simplified the entire process as we have been doing this kind of things every day. This is a concrete pump. Now, how a concrete pump is been designed for say to throw concrete at 10th floor or a 15th floor, how you can modify it to 20th floor design. Okay, this is the gearbox. How to design input and output shaft diameter, or how to design a ratio in between. What will be the MOC of this input output shaft diameter? What kind of loading is getting transfer? What is the say dual loading or triplex loading is been taken into consideration in this calculation. So whatever projects you see that has happened in the training session itself, okay, and we go little bit fast, and you will also understand that okay, you see this particular it is all machines. There is no book available where any of these machines design is available or has been defined from start to end. There is no book available. All formulas you have to apply from where to start and how to start. All components you see this particular conveyor system, but how to design this particular stuff? What will be the pitch between these two blades? Okay, if you have to transfer X tons per hour, what will be the design of this particular U structure? What will be the bearing size here? What kind of loading it will take? What will be the HP or gear ratio to run this kind of system? With change of load, how the HP and gear load and the size component size is vary. See, mechanical engineering is a very challenging field for software people also, because they have not been able to derive any say common software which will define any of this flow design from start to end. In chemical, they have got a very predefined software and standards, but mechanical engineering it is not been made possible because there are thousands and lakhs of products in mechanical engineering. It is not possible for any software to give complete design. So we want to make you a creative designer. At the end of the session, we want to augment your knowledge to such a level and your thought process from a normal engineer to a professional engineer, we'll call it. We want to make you a professional engineer. That once you see this kind of structure, your mind should start calculating which is the weakest portion to design and which is the maximum load taking portion which has to be designed and how it has been designed. How the HP has been arrived here, how the HP has been arrived in this drum. What will be by rope size? What is the standard method? Not jugglery method, but what is the standard method of calculating this rope size? So be part of the program, and we assure you lot of knowledge. I will say lot of knowledge that will be helpful to you throughout your career, and a formula tricks and a way of thinking as a design engineer that will make your self performance as a designer much more improved. If you are taking, say, we said any design you take, we complete within 3 hours or 1 hour or 2 hours. You take any design. Now we want to train. During training session itself, we complete the design. within 3 hours or 2 hours or 1 hour. Once you will start doing this kind of exercise, your speed of designing any equipment, any machine, any system, cracking any new system becomes so much fast that you'll start enjoying the real engineering, the real flavors of formulas, the real flavor of mechanical engineering. Okay. It is a very challenging field, mechanical engineering, and we all love being an engineer. Now let us accept this particular challenge. And as far as the career is concerned, basic engineering is the highest paid job in any company. You see the bosses, design bosses, they are very good at basic engineering. They don't know what is SolidWorks, they don't know what is ANSYS. Okay, but he will throw out the entire design within 2 hours. He will tell you that component to component design formula. What software does help? They will help in analyzing the things, analyzing the systems, or re-engineering the systems, which were not possible without making any practical model. Without practical model, if you want to run, then some simulation, that such kind of run has made an engineer visualize, okay, this is the simulation, it has been running. But there is a lot of difference between a software design, which is, if we replace the software design 100% to physical, then that design is never successful. There is a lot of difference between the physical design and software design, because a lot of factors which software cannot take care, very human brain can take care of while designing any component or any machine. See, if the shaft is X-ray, software understands everything. There is no cracks, no hair cracks, nothing. The strength across the say core, across the diameter is same, but it is always not true in case of big shafts. There are a lot many things which software don't understand, which the practical brain understands and put that kind of factor of safety. So, if you want to be a complete designer, from basic engineering to detail engineering, it starts with basic engineering. If your start is good, then your career is going to jump, leap, and bound. We are charging small fee for this kind of training, 40 hours, but it is what design fundamentals we share. It is lakhs of rupees of each and every fundamental. I tell you, each and every display design, this kind of design, it's been charged lakhs of rupees. It is not very few people in India are capable to design this kind of machines or multiple designs. And if you want to be a member of this kind of few people, then join our training program. Thank you. Thank you. See you.